My name is Heather Doran. I'm the Public Engagement Manager from the Leverhulme Research Centre for Forensic Science. I'm just going to give a few announcements here about the event this evening. Thank you all for coming along. Just to let you all know, this event is being recorded and we have an online audience as well. So just bear that in mind. If you do ask a question, other people can hear you as well. So welcome to our online audience, as well as those of you that are in the room. This one is for those of you that are in the room. If the fire alarm does go off, then we do have to leave. It's not a test. So if you exit via the door that you came into, and we will guide you out to the fire muster point. I think that's all I have to say. We will have some time for questions at the end, and our online audience can also ask some questions through the Q&A as well. I'm just going to get the thumbs up from Clara to make sure that that's all working okay before I hand over to Professor Niamh Nic Daeid, who's the Director of the Leverhulme Research Centre for Forensic Science.
Thank you very much indeed, Heather, and welcome everybody. I'll add my welcomes to those of Heather's. As Heather said, my name is Niamh Nic Daeid. I am the university's Professor of Forensic Science, and I am the Director of the Leverhulme Research Centre for Forensic Science, of which this is our 9th annual lecture. We're enormously pleased to have Dr. Sheila Willis with us. Sheila's been a good friend to the Centre since its inception, and indeed before that. And so we're very pleased to have her with us. I'm not going to say any more. I will deal with the questions and answers at the end. I shall be your MC. And we'll talk about how we'll run that towards the end of the presentation. But for now, I'm delighted to welcome Professor Blair Grubb, who is our Vice Principal Education and who will do the formal welcome for Sheila. Thank you very much indeed, Blair.
Thank you very much, Niamh. That's fantastic. So, ladies and gentlemen, honoured guests, I am absolutely delighted to be invited to introduce our guest this evening, Sheila Willis. Before we hear from Sheila herself, I'm going to read out a small number of Sheila's amazing achievements and contributions in the field. Starting with Sheila's qualification, she studied at University College Dublin, where she received a PhD in organometallic chemistry. For most of her career, Sheila worked at the Forensic Science Laboratory in the Republic of Ireland, where she was Director General from 2002 to 2017. From 2017 to 2019, she was a guest researcher at the National Institute of Standards and Technology in the US, reviewing the scientific foundations of DNA mixture interpretation. She also chaired the Association of Forensic Science Providers from 2006 to 2009, and she represented that group on the UKFS Regulators Advisory Council from 2007 to 2010. She served on the editorial board of Science and Justice from 2007 to 2014. As if that wasn't enough in terms of honours, most importantly, Sheila has a fellowship of the Leverhulme Research Centre for Forensic Science, which is undoubtedly her greatest accolade. She has an honorary doctorate from UCD, which was given in 2019, and another one from the University of Lausanne in 2024. Sheila is a supporter of the need to emphasize the foundations of forensic science and chaired the group who produced the ENFSI guidelines for evaluating reporting. She was also one of a group that formulated and promoted the Sydney Declaration, which seeks to shift the discipline's dominant focus on forensic analysis and methods to a more trace-centric and context-based approach. The accolades and contributions that Sheila has made to the field are endless, and you certainly don't want to hear much more from me. That is not to belittle all of those that I haven't mentioned. Much better we hear from Sheila herself. Now, with decades of experience in global recognition, Sheila will take us behind the scenes of forensic science, exploring how science meets justice, the evolving role of technology in investigations, and the critical human judgment needed to solve crimes. From lab to courtroom, we will discover how forensic science needs to balance technology and human assessment. Ladies and gentlemen, honoured guests, please join me in welcoming Sheila Willis to come forward and present the Leverhulme Centre for Forensic Science annual lecture for 2025. Sheila, please come forward.
Thanks ever so much, Grubb. I could start by saying I don't necessarily recognise that individual. That's not really true. Some of those things are me, but I highlight before I start as somebody who's technologically inept by not being able to switch on the microphone. So I need to check. Can you hear me? I'm fine. Okay, grand. It's a real honour and privilege to be here to deliver this lecture tonight. And I want to particularly thank Professor Niamh Nic Daeid, Heather, and anybody else who's responsible for my being present. And I hope that I can justify by speaking a little bit about some of the areas that I'm passionate about in relation to forensic science. I entitled the talk Challenges in. See, I'm being challenged already. Okay, yeah, we got it. I entitled it Challenges in Forensic Science, and hopefully that'll make sense as we move along. And then I sort of thought, well, why me? The Leverhulme Research Centre for Forensic Science was set up with the mission of being a disruptor. And from what I hope that you heard a little bit from Grubb about me, I've been kind of part of the establishment. I spent 38 years as an employee of the Department of Justice, and you don't get much more establishment than the Department of Justice. But to add to that, I was working from Garda headquarters, which is the Irish police. So very much embedded in the establishment. But I was privileged to be part of a small group who were in the early phases of setting up the Forensic Science Laboratory. So had the challenge of establishing things from first principles and setting up systems. And that was really exciting and gave me lots of opportunities that maybe not everybody would have. But since retiring from the establishment, I've been on the outside looking in, and I realized that you do get a different perspective when you're not part of the system. And what I hope is that those two perspectives, kind of the independent expert and somebody who's been very much part of the system, should be in a position to comment on the state of forensic science today, or what are the challenges or issues that we need to address. Now, during my career in forensic science, I've seen lots and lots of changes in relation to science, and it's been an amazing journey. The value and the contribution that different advances have made is just nothing short of phenomenal. There's the only restriction in analyzing something at the moment is how we actually get it to an instrument. I mean, it's sometimes the physical size, it's the handling item, or the matrix in which it's embedded or something is the restriction. But there's no such thing as a detector that's going to stop you being able to analyze. But the big paradigm shift, of course, happened in the mid-80s with the use of Alec Jeffrey's realization that DNA could be used in forensic science. And although people are well used to the story, I think it's worth reflecting a little bit on the different aspects that came to light almost the first time forensic science was used, because I think it's important for us to remember that. First of all, it exonerated somebody. And in forensic science, we're very inclined to think in terms of cases where the findings actually point towards the guilt of somebody. But this was one where somebody was exonerated. There was a broad range of people tested, which was very, very out there as an activity at the time. And the third thing I think is very important to remember is that the technology didn't actually identify the relevant person. It actually was, it was necessary to have active police work and somebody talking loosely in a pub to properly identify the individual. And I think it's worth kind of remembering that when we think of modern forensic science, we think of DNA as being kind of really a fantastic advance. And yet we have to realize that it's not a standalone something that you can use as a silver bullet and identify the perpetrator or the person responsible. And then we all today live in a digital world, especially since COVID, I kind of shied away from technology a little bit until then, but we now live virtually half, or at least a percentage of our time. I mean, who would have thought 20 years ago that there would be people sort of, you know, who could link in online and ask questions and almost be as active as the people in the room. It just was beyond our comprehension. But that's our life now. If that's our life, that's also the criminal's life. And if that's the criminal's life, that's also forensic science life. And so the whole digital area has expanded hugely. I'm not sure that we're well equipped to actually get the best value from it, but nevertheless, it is an advance that we need to think about. One of the disadvantages of forensic science is that each time there's one of these shifts when new technology comes on in a major way, there's a tendency for us to reinvent the wheel and sort of forget the principles that were in place for the previous one. We'll speak more about that. So what I'm saying is that in spite of all the advances we've had in science, that there are definite pitfalls. And some of the pitfalls I'd already alluded to beginning to talk about, that we don't build on what we already know, with a tendency, like I say, to try and reinvent the wheel. And we sometimes, or maybe quite often, can come up with findings and we've no idea what they mean. And sometimes we use them anyway, which is really quite a bit of a problem. When we're talking about trying to investigate crime, we're looking to know when, why, where, what, and how. And we need to be raising those questions rather than just coming up with associating two items. When I think of forensic science, when I was early in forensic science, I had this tendency to think in terms of, oh, it's science used in court or it's science used in crime. And of course it is, and science is pretty universal. But forensic science has particular constraints related to it. I'm not claiming that it's a kind of a unique one-off thing, but there are constraints that affect how we use the outcomes of our examinations. And I think of 3 C's, where I think of the crime scene. Now, I know there are people here who know much more about the crime scene than I do, but I have been at a few, and any of you who haven't, well, I think we have to accept my word that it can be pretty chaotic. It's not a nice pristine thing where, you know, the traces kind of say, pick me. It's pretty chaotic. The context is important in forensic science, and I will refer to that as I go through the talk. And then contamination avoidance. We're hoping that the materials we find at the crime scene, the traces we find at the crime scene, may help us to give some indication as to what's happened there. But of course, material is not time related. You know, again, it doesn't have a little flag on it saying, you know, this is only here since 6 o'clock this evening. It may have been there since last week. So these are all areas that actually cause problems for us. If we think about context, the top row there, which I had tried to animate earlier on, but decided it was too tricky and that I'd lose track of clicking the thing. There's a major difference between finding DNA association between a couple that are having a row or a married couple where one kills the other versus a stranger rape. You can tell that they're going to have completely different impact, because in one case, of course, you expect the DNA to be present, and in another case, the DNA can give you really useful information that will help the investigation and may even be possible to evaluate the context of the crime later on. If you're somebody who fires a gun and the incident happens in a church, it's much less likely that you're going to get contamination of GSR, which is generated when you fire a gun, as you see in the 4th slide over there, than if it's at a firing range, for example. So the findings are the same, but the inference that you can make from them is completely different. In the digital world, I think I'm not sure that I can speak for anybody other than myself, but there's a tendency to think that if you get something up on your phone that it has to be right, you know, that the time is right or that the information you're getting is correct. But I know from speaking with colleagues that there are lots of problems with the digital world as well. And it might be something as trivial as you triangulate to try and find out where a particular phone was at the time. You get some information about that and find it's in the same area as the house of the individual you're investigating, which is absolutely pointless, but sometimes that you'll go to all that trouble to do it without thinking, what are the questions we're trying to address by carrying out this work. I said there was amazing advances in science, which I definitely stand over, and that there are some constraints in forensic science. But regardless of the constraints, what's happened in the last 40 years or so, that the demand for forensic services has expanded exponentially. Across the world, every laboratory has loads of demands on their time. And while on the one hand, that would seem like, well, that's quite a good thing, you know, people see the advantage of getting value for this thing. On the other hand, as with everything in life, there's a downside. And the downside is that the whole energy of the system drive towards getting through the work. Again, you might say, well, what else would you do? But it might mean that there are shortcuts and different effects of getting through the work that's actually working against the fundamental purpose of forensic science. And that might be one of the causes, I'm not suggesting that it is, for the fact that throughout the time we've continued to have very major miscarriages of justice. And when we have miscarriages of justice, a lot of focus comes on the field, that there's need for change. There's been, this is very much the case in the US, where there was a big report, multiple big reports, and a lot of focus on the flaws in forensic science. And the solutions that tend to be suggested are technological solutions. You know, we'll get a different technology that will help us, or we will accredit the system, or we'll try and chase down, are there more errors in this particular evidence type than another? And while those solutions or approaches have their place, they are not sufficient to solve the entire system. And some colleagues, and sometimes on my own, I've written some sort of warnings that maybe accreditation, wonderful and all it is, and I'm quite a fan, is not necessarily going to solve everything that we expect it to solve. The conversations about these challenges in forensic science and what we could do about it were taking place among several of us across the world, usually over a glass of wine, could I say? Usually at conferences, and really focusing on similar points all the time. So in, I think it was it 2020, there was a decision made that we should try to formulate a declaration called the Sydney Declaration, because the IAFS conference was due to be in Sydney that year. It was put back for 3 years because of COVID. I have up on the board there the front page of the paper that was produced from it, and the authors, some of who will look familiar to you, I expect. I run into difficulty now because one of the big advantages of the Sydney Declaration was that we moved away from this trivial, unhelpful definition of forensic science as being science used in court, and we formulated a definition. It's an awful mouthful, and I'm not sure I'll be able to say it without reading it, and I won't be able to read it all that far up there, so I may have to move across here. Okay, so the definition is that it's a case-based or multi-case-based, research-orientated, science-based endeavour to study traces. Traces being the remnants of past activities, such as an individual's presence or actions, through their detection, recognition, recovery, examination, and interpretation, in order to understand anomalous events of public interest, crime, security issues, and so on. Some of those words will be particularly familiar with anybody who's working in the Leverhulme Centre, because I think they may have been lifted directly from it. But it's a very comprehensive definition that I think encapsulates the work that forensic scientists do. And the focus very much is on traces. So what do we mean by traces? Or why are we saying traces? It's because, in effect, what we're trying to do in a shorthand way is to shed some light on a past event. If we're investigating a crime, it's a past event by definition. And very often there's a time issue that's going to interfere with what happens to material that might be shed or transferred or moved at a scene. And so therefore, the traces may not fit the pristine condition that we have with reference samples. Another challenge, if you like, for the forensic scientists. And that example I was thinking of, and I'm not sure how helpful it is for people in the audience, but at one stage in my life, I did a lot of ignitable liquid analyses, and that were thought to have been involved in, or came from, not thought to be, came from fire scenes. And you rarely ever got a chromatogram or a profile of the material that matched the reference sample, because of course, any volatile material was lost in the course of the heat of the fire. So what you were left with was a trace. The other reason that I think it's useful to think in terms of traces is that what forensic scientists are trying to do with their microscopic samples is what people have been doing forever. I happened to be in Belfast at the weekend, and the Titanic, of course, is a major feature. And a little video was of David Ballard talking about that the reason that he was successful at finding the wreck of the Titanic when so many other people didn't was that instead of looking for the Titanic, he looked for the traces. He looked for the debris that came in the wake of the ship as it crashed, and that led him to the site. And I thought to myself, well, you know, nothing changes really. And he said that the reason he did that was because he was used to shooting deer, and that you would always follow the footprints of the deer in order to find the deer. Now, we don't usually have the luxury of either footprints or debris from a shipwreck, but in essence, we're doing the same thing on a microscopic level when we're talking about traces at the scene. So what is the process that we're looking at? We're essentially looking right from the crime scene to some kind of a decision making, usually a court. And at the crime scene, I've already alluded to the fact that it might be a fairly chaotic situation. And if it's physical samples as opposed to the digital world, we're moving it back to some area, to a laboratory. But somebody makes decisions even then as to what items might be submitted to the laboratory. So there's a prioritization system. The laboratory is the area where there's been, when I said that miscarriages gave rise to technological solutions, the technological solutions are almost always focused on what happens actually in the laboratory, whereas the uncertainty is much higher in other areas. The uncertainty even in relation to the communication aspect. The output from most laboratories is some form of report, some of which, when you read, you really sway and wonder what is being said here. And somebody takes that report and speaks to it in the context of a court where they're speaking to lay people, and we're surprised then that sometimes gibberish comes out, but sometimes it does. At least to the ears of the receiver, it's not always clear. And yet we continue all the time to put our focus very much on the laboratory solutions, as though the rest of the system, which is just as likely to give trouble, if not more likely to give trouble, as though the rest of the system is quite in order. If I wave back to the Sydney Declaration, we focused on principles. Now, I have to emphasize that there's absolutely nothing new in what's written here. And there was some chat and criticism about, oh, the Sydney Declaration was a very academic piece of work. It's almost true to say it's a statement of the obvious. But the trouble is that the obvious was being lost in the drive to get through the work piles. Processes are being put in place to get through as many testing samples as possible, and maybe losing some of these principles. And the principles are that activity, and they're easier to read again, and presence produce traces that are fundamental vectors of information. That's the items that come from the scene, they're the vectors of information. That the scene investigation then is not a bag and tag operation, that it's actually a scientific endeavour. And that forensic science is case-based and relying on scientific knowledge, investigative methodology and logical reasoning. There's a bit of a worry in my mind that science is sometimes mistaken for technology, and the aspect of making logical inference is sometimes forgotten. But logical inference is a very, very important part of the scientific process. Forensic science deals with the continuum of uncertainties. Again, if we talk about it being science, science is about quantifying our uncertainty, not about given certainty. And when we say that it has multi-dimensional purposes and contributions, what we mean there is that we're probably not getting the best value from the outcomes. As things stand at the moment in a typical forensic science laboratory, samples come in, work is done, individual reports are put out. There's a lot of money that goes into the kit that fits this part here of the laboratory side. So the barriers to entry are quite high. But there's so much information in the files in forensic laboratories that surely we should be able to get some better value from them in some way, either as a crime prevention or identifying crime hotspots or intelligence. I feel sure that there's some future in relation to something like that. And the final principle is that forensic science acquire meaning in context, which I've already alluded to and used an example. And there's some criticism of the fact that perhaps forensic scientists shouldn't know the context. You know, forensic scientists should be isolated and purer than pure and produce some kind of outcome that are objective. Because what we actually want forensic scientists to be, we want them to be transparent, independent, impartial, and we want the work, of course, to be based on science. We want to avoid half-truths that are opaque and don't have foundations or that prop up one side or the other. And you know, when you see it on a slide like that, you think, well, you'd always opt for the angel rather than the devil. But I can tell you that an adversarial system where you've produced a report and you're defending those findings in the context of another context, but yet it actually calls for quite a bit of, I would say, courage and integrity in order to do it well and not to be swayed and used as a pawn in the game, to stick with the basis of your science. So I think the people who I expect to be the angels should have some power, good processes, and the people themselves need some characteristics. So what do I mean by that? I think the people in the system need, obviously, to be competent. But I would move away from competent being, you know, I'm able to do this little bit here. I expect a competent forensic scientist to have pretty broad scientific knowledge, to be educated rather than trained, because the training suits for this time, but in a field and in an area where things change so quickly, you really need that good foundation. So you need the foundation, but you also need continuous professional development. And that doesn't always fit the modern era of needing to just get through the work. You want people, I say, who have a public service ethos, and that's nothing to do with whether or not the work is provided by private or public sector. I just think it needs people who really want good outcomes from a justice point of view and have good integrity. In relation to processes, we want the right people in the right place and an ability to be able to, if you go back to the definition, that big long definition that said a research-based endeavour, we didn't mean necessarily that people were going to be doing, you know, blue skies research out on all sorts of topics. That can be dealt with in an academic environment. But what we did mean is if you encountered a case where you had an issue in a case, The scientific method says you test. The only thing we can be sure of is the results of tests. And so there should be the opportunity there to actually test something. I try to learn from most things that I do in life. And one of my very early influences, Michael Norton, I worked with in the laboratory, and he rarely ever would put out anything without testing the what he thought was the case. We don't always have that opportunity, but as time goes on, we're getting less of it. I think it's important to build it back in. And I think that, again, if we look at the process, that we have the people with the highest risk is as you go to which side of that you're looking at it. So this side, going to your left, is the highest risk because there are the fewer controls, there's the less chance of actually checking and repeating. Where we have the most controls is in the laboratory. And I just raise a question, are we, have we got the education system right that we're working the way we are at the moment? Is that process correct? And the final one I put in is power. And the reason that I put that in is that I used to think in terms of the progression of forensic scientists over about 100 years. And we had the kind of all-powerful, usually pathologist, individual giving evidence that nobody would ever dream of contradicting. And once they said something, that was right. And then there was a realization that actually, sometimes they're wrong and we have to change that. And so we moved, this is very in a global sense, we moved towards a more process approach, and no one individual was considered to have all the answers, which is true. But to my mind, we need to actually move back and put the people back into it as well, because no system is going to work unless you have competent people and you give them the power and the authority. And the reason I put the white coat there is that there's a lot of pushback on that and saying that, well, actually, once you speak as a scientist, that people believe what you say, whether it's right or not. And I'm saying in the forensic science world, you need a little bit of both. You shouldn't be arrogant. Obviously, you shouldn't be arrogant, but you do need to give power to people so that they don't stick rigidly to a recipe and have the authority and power to actually move outside it when it's necessary. Binary solutions are not good to most things. Most things are not either good or bad or somewhere in between. Certainly in forensic science, mostly the findings are somewhere in between. And what forensic science provides to the criminal justice system is a level of support. Unfortunately, we've had over the years a lot of scholarship in relation to this. And so we have principles of interpretation, which you needn't worry about the formula, but the circled piece is to concentrate on the context. And I've already made a reference to context at least 3 times during the talk. But this slide is another illustration. The piece taken out on the left-hand side of the slide would have a very different meaning if it was standalone and if we didn't have the rest of the picture to show that it's only part of the picture. So findings take meaning in context. We need to think in terms of looking at least 2 propositions if we're going to evaluate something. We need to, if we're going to provide balance, and if you think of my context lady with the devil and the angel on either side of her, if you're going to try and be balanced, you actually have to look at something from at least 2 perspectives, as opposed to, again, thinking that there's an ideal solution that's going to come up with a name and a number for you. The final one is one that's often abused a lot, in that the forensic scientist has the ability to focus, when they're evaluating, to focus on the value of the evidence. And so we can say that a cow has 4 legs, but just because the animal has 4 legs, it doesn't mean there's a cow. We know there's lots of alternative examples. And we sometimes fall into that sort of trap in forensic science, in making the wrong inference by thinking that we can say something about the hypothesis or about the scenario. And in fact, what we can do is how likely are the findings. So lots to be done if we're going to try and make progress from the fantastic advances that there are in science or in technology. But we want to be able to be sure that we're using logical inference, some of which is implied on the last few slides. However, we need more than just forensic scientists. And speaking as one of this band, managers and leaders need to provide the necessary resources. And I put this slide up, and in case you missed this kind of the relentless demand arrow, I couldn't emphasize it enough how much of an impact that actually has on how the system works. Because and anybody who kind of keeps up to date or looks at the literature, there are instances where it's clear that high demand is one of the things that causes problems sometimes, cause people to make decisions or shortcuts that are not welcome down the road. So managers have to be really conscious of ensuring that the resources are there, or that they don't give in too much to the relentless demand. And they need to encourage a scientific culture, encourage that culture of testing and skepticism, rather than just rely on, we've got a method now, let's run with it and do 10,000 samples with this method. All the accreditation systems talk about continuous improvement, but continuous improvement means that we have to be willing to accept mistakes and that people are not chastised or thrown out for making mistakes. I think some level of deference to expertise by managers would be a good thing, and very much avoid being a postbox, by which I mean just passing the problems on. If you're going to be a leader in an organization, you've got to be willing to look after it in some way. Now, what we measure is what we get. That's, I mean, lots of people chat about that when they're talking about any kind of systems. So what do we measure in forensic science? We measure numbers and we measure turnabout time. Neither of which I've made any reference to when I was talking about what I thought to be the challenges in forensic science. So we actually need some better metrics that enable us to communicate well with our stakeholders. And who do I mean by our stakeholders? I mean the budget holders that are providing the resources. I mean the police that are making demands on the service. I mean the courts that deal with their specific case at this time and no other. But as things stand at the moment, that's a big gap, and I'd be delighted if somebody has a solution to that. I'd be on a real winner. Some of the issues that I've been talking about, I was very pleased to work with colleagues across the world, and these two papers I want to refer to in particular. And one is that not enough research is devoted to forensic science issues as opposed to laboratory issues. You know, the literature is full of references to this instrument and that instrument dealing with a particular item, whereas in actual fact we need research on the questions, strengthening the links in the chain right from the court scene down, and I've already made that reference. And in the same way, we want forensic science questions and not just technological questions. So you'll be glad to know I am finished talking, or close enough anyway. What about the future? I have no idea. Neither does anybody else, I suggest. But I'd be surprised if we don't have an ever-increasing focus on the digital world and on AI. And if that be so, we need to be better prepared than we are today. We need more work like the type of work that's been done in Leverhulme in relation to trace and transfer and persistence work. Because when AI begins to be used to tell you what the source of that trace was, they can only use the material that's there, that's already on the internet. And like if it's from a Star Wars movie, that's what's to be expected. We need good, hard data. And I think it's the same thing. I'm just repeating myself now, so I'm getting a bit bored with my own voice. And instead, I will move on and say that I'm very happy if anybody has questions that they would like to raise. Yeah, so why not? Thank you.
Thank you, Sheila, very much indeed. That was really insightful. As always, whenever I listen to you talk, I always learn something new. and a different way of thinking about things. And so thank you very much indeed for sharing your insights with us. We have some time for questions if anybody wants to start us off.
Thanks, Sheila.
Oh, could you just, sorry, wait for the microphone. Sorry. That was the one thing I had to do, wasn't it? Was to give the instructions about the talk.
Thanks, Sheila. That was great. So you spoke about, obviously, tests get standardized and everything becomes uniform in order to increase reproducibility. But at the same time, you say that testing process produces almost automatons who don't think about what they're doing, may report wrongly. How do you strike the balance between standardization and people standing back and taking an overview so that they don't simply report results, but think about what they have seen?
Yeah, I don't have an easy answer to that question, which is a very real question. I think we probably don't emphasize CPD enough in the environment. I mean, we've been such a successful story in a way that the tendency is just to get more and more outputs and somehow forget that you need to feed those outputs to ensure that they're the relevant ones. And that means continuous development. And I suspect that there's not enough of that. I think in terms of focusing on making sure that people are given the right answer, sometimes people need to see maybe the result of mistakes. The impact. Yeah.
Do we have the next question? Yes. Thank you.
Thank you, Sheila. That was a fantastic talk. I was just wondering do you think that the lab aspect gets so much funding because that's almost like an understandable science? Regardless of your background, you're used to being in a lab, you can kind of follow the processes. Whereas when you go in, if you're in maybe a more traditional discipline of science, you look at a crime scene and it does look a bit like junk science because it's just stuff scattered about the place. And there's that misunderstanding as well going on.
I think I agree with you very much that some of it is we haven't been good at, I would almost say, promoting the system. I know I was guilty of that when I went first, that the solution was in the laboratory. And therefore, you know, if you have the laboratory working well. But I mean, it's a really good example of junk in, junk out. And not only junk in, junk out, but sometimes the laboratory is made incredibly difficult because the right material doesn't come in. It mightn't be total rubbish that goes out of it, but it could have been done much better or much easier if there had been a better understanding of the science. You know, Peter DeForest, that a lot of people would know, sometimes talks about forensic science as being like an archaeological science with a different time base. And who would ever think that you could do archaeology from a laboratory in isolation from the scene? And yet I know the scene gets some focus, but it doesn't get as much focus as the laboratory. And there needs to be better linking, I suspect.
Here.
Thank you very much. That was a great talk. I'm really interested in failure and how we talk about failure in science generally, but particularly in forensics. How do you talk about failure without the public losing respect, support? I think it's a big challenge.
I think it is a huge challenge and probably is improving as time goes on because there's a recognition. I mean, there's been dramatic failures where there's big miscarriages of justice, but not enough recognition that you need actual pointers further back on the system so that you catch the failures before they become the big miscarriages of justice. So because of that, accreditation got a lot of credibility, some of it justified, I would say, but not totally, and it's not the total answer. And it would be kind of difficult to stand here and say, oh, we celebrate our failures, because we don't. I mean, who does? We're there thinking, oh my goodness, imagine I could have gotten that wrong. So it's a difficult question, and I'm not sure that I have an easy answer for it.
Down here at the front.
Thank you, Sheila. You just mentioned their accreditation. I was just wondering, what are your thoughts on the impact accreditation has had on that education of the actual specialists because of the implementation of SOPs and following the standard and reporting how many times you got it wrong, et cetera, in the lab? Do you think accreditation has taken it too far and taken away that education of the individual?
I think we rely on it too much. I think it's an amazing system if it's properly used. And so I hated when I heard your question, because I thought, you know, I could easily, no, but I could stand and sort of say, you know, it's really bad and it's bringing us down a wrong road. I don't believe that, but I think it has been responsible for giving too much complacency, because there's a kind of a belief that, well, if it's accredited, it must be okay. Yes, and not thinking sort of from first principles. Now, you don't want to be thinking from first principles for every single thing if you get loads of the same thing. But I think there's a balance somewhere or another. And I think probably one of the most important people in a laboratory is the quality manager. And if you have a good quality manager, then I don't have a worry. But a lot of places use a quality manager post as a role for somebody that they're not sure what they're going to do with. And you know, it's not a helpful situation. You absolutely need a passion, and you need somebody who has great judgment and good balance to drive it in the proper way.
I know we're also, of course, still broadcasting online, so I think there are a few, or at least one online question.
Yep, we have one online question. This one is also about education. So they're asking, how do we support graduates' experience when they are not given opportunities after university?
Oh goodness, I think you're talking to the wrong person if you're talking to me there. I think how could I possibly say in a university environment? Rescue me.
Part of it is, I know we have some colleagues here from Forensic Services, the Scottish Forensic Science Laboratory, and they've just begun a new scheme where they're looking at bringing in modern apprentices to try that process to see whether or not that would provide the right quality. I'm looking at Vicky here, the right quality or the right type of employee. And I think that's a fabulous idea, because it brings people in from different areas, not just the university track. The kind of scientists and technical staff that we need will come from all of these different tracks. But we live in a very regimented, traditional educational model when it comes to forensic science. And I think we held one of our strategic conversations last year that Sheila actually was at, where we looked at what is the right educational model for this area, and where do we take those steps, and what pathways are the right ones to follow. And we're at a position, I think, a point of inflection in time, where we have some time to try to get this working a bit better than perhaps it currently is. I don't know if Sheila would agree with me, but as you said, and I was very taken by it, we have a huge challenge coming, which is the next big crossroads we're standing at, which is about digital and AI. So we need to empower our future forensic scientists to be cognizant, to understand all of that, and to be able to work within that environment. I don't know if you want to throw anything else in there, Sheila.
No, I'm trying to think of anything useful to say on it, and I'm not sure that I do. I think how we train people and how we use people to get the best is quite a challenging thing. And there's kind of opposing kind of tensions, if you like. On the one hand, because of the demand for forensic science, there's a drive to get more and more through, you know, get more and more samples, more and more things through. And then if you want a kind of a bespoke product, you have a tension in the other direction as to how much time it takes. So getting that balance is quite tricky, and I wonder whether I'm absolutely convinced that we have the right training programs. Like we haven't agreed what an ideal training base is for forensic science, because it's such a mix. I mean, some people would say there's no such thing. Other people would say that almost every science has the potential to be forensic science. But one of the reasons that we were keen to write up that Sydney declaration paper was to identify some of the things that can kind of get lost in that mix of there not being a clear platform as to what forensic science is. I think I've moved off to the topic now. Sorry. On my soapbox. Excuse me. Sorry.
Do we have another question? Yes, up the back. I'll come to you just a second.
Hi there. A bit of a disclaimer. I'm not a scientist. I sort of get a lot of my forensic knowledge from daytime telly, so my apologies. But I'm fascinated with things like the data sets that, for example, laboratories in Perth collected thousands and thousands of fibres to solve crime, and for example, the James Hutton Institute that collects thousands of data regarding soil. But that's my question is, if you were to collect data sets to train your own AI to help with forensic scientists, where would you draw your data from? Would it be worldwide? Where would you start?
Well, it's such a big question. I'm not sure I can answer your question. In fact, I can't answer your question, but I can just make a few comments based on it. The data sets, I mean, are really tricky because they're dependent on what you're going to use the information for. And worldwide data sets would probably be of less value if you're dealing with crime in Dundee, because you're going to have different factors than if you're in Brisbane, for example. So I wouldn't be that keen on worldwide. But the other challenge is that data sets that you collect have a time-based feature as well. So something that's particularly, for example, I think somebody made reference to fibers at some stage from clothing. They would be particularly linked to fashion at a particular time. So you'd have difference between summer and winter. You'd have difference in color over time. So it's a really quite a tricky question, actually. So that's as much as I can tell you. Pardon? Well, the AI is, yeah, the AI is going to be a big problem area, obviously, because in the beginning we might be very careful, and then as time goes on, we think it's able to do everything for us and forget our fundamentals.
We have a question up the back and then one down here at the front. So just beside you there, Heather.
I'm very interested to know where you think the balance should be in terms of the justice system is very into validation and robust, reinforceable. It's been done before in case law. That's how it carries forward for evidence. How does that balance with the new innovations and technologies that everybody's making wonderful papers about?
Give me a clue as to what you mean by the wonderful things in papers.
So new techniques in terms of things like non-validated techniques for DNA extraction purification, or new techniques in terms of recognizing shoe prints.
I don't think I'd be that keen on using either of those without some kind of validation. In fact, I wouldn't have. I thought you might have meant something more electronic, which is more difficult because the rate of change is so high. But for those two examples that you used, I wouldn't see any reason why you wouldn't have a validated system. And I mean, let's just kind of review what we mean by a validated system. Really, that we have some trust that the findings that we have some value. It's little more than that. And of course, that's quite challenging in a forensic science world, because I mentioned the word traces, and we might validate something on pure materials and then find that actually we seldom get the pure materials because they're generated and changed in the course of aging, for example. So it's actually a complex enough area, but I think while I was asked about accreditation and maybe gave a nuanced answer, I would be reluctant to opt for ignoring validation.
And we have one yourself down here, then front, making Heather keep up her steps. And we'll just check while we're just waiting there. If anybody else online wants to ask a question, then please put one into the chat.
Thank you. I'm conscious, and a lot of us now have our DNA held in databases, whether that's Ancestry or the sensitivity around is it 23andMe or whatever it's called. And I also noticed we've got our wee card on the desk here. I'm just interested to know one, where public policy is internationally on that, and where you see it going, where you would like it to go, ideally from a forensic point of view.
Ooh, big question. There is no public policy as far as I'm aware. The technology that most of the ancestry systems are run on is different from the ones that are used in forensic laboratories at the moment, whether that will continue to be the case or not. There was, I remember in the early days of DNA, the school of thought that says, well, you profile everybody and put them on big databases. I don't think I would be very much in favor of that. And apart from not being in favor of it from a privacy point of view, there's always, very often, there's some side thing that's nothing to do with the technology that ends up being the problem. So I'm not sure that I've answered your question, but I wouldn't be in favor of universal databases.
We have one more question online, so we'll hand the microphone over to Clara, and so we'll take one more question in the room if there is one just after this one here.
Okay. So apart from AI, what other challenges do you foresee in our future for forensic science?
Oh my goodness, challenges in forensic science. I think challenges in forensic science focus on ensuring that we remember the various things that feed into uncertainty, rather than thinking that a simple answer is. Sometimes we do things because it's simple. Sometimes we do things because we have that technology available to us. And I think we need to stand back and check that we're getting all the uncertainties when we're addressing. I would also say that for me, there's little or nothing that I think a single item is the answer. I would expect things to have a coherent story going through them. And I think we probably need education in relation to that of the users as well as the providers.
Thank you. Do we have one final question in the audience? Yes, please.
Thanks very much. Hopefully a quick question, but maybe not. What do you think could be done better in the courtroom aspect of the chain? You kind of mentioned it, but you didn't really go into any detail about that compared to kind of, for instance, the context, the lab, and so on. Whether that's kind of better communication, better understanding, better interactions with the lay people. I'm coming from, as you may know, from a legal perspective, and I think generally we're pretty rubbish at understanding forensic evidence, but others can correct me if I'm wrong.
Yeah, I don't think you're rubbish. I think sometimes you're too quick to catch us up. I think one of the problems might be the duration of our present legal system, and that maybe better agreed outcomes from conflicting experts might work better at giving an opportunity to tease out what are the real issues. In the present system of kind of, you know, put it up and knock it and somebody else knocks it again, I don't think you get the nuances necessarily. And I think maybe an agreed system. Now, whether that would fit with, I don't think it would contravene any fundamental law, because you could still have the contested case later on, but to get through the undisputed material between two experts, I think would be good.
And that's a wrap. Thank you, Sheila, so very much indeed for giving us your time, your wisdom, and a really fascinating and interesting evening. If you put your hands together again, please, for and it remains for me to do a few thank yous. Firstly, to my team. There are a number of people from the Leverhulme Research Centre for Forensic Science here. Particular people I will pick out are Marge Davies, our Centre Manager, Heather Doran and Clara Morris, who are our public engagement team, who did all of the hard work behind the scenes here in order that we could have this evening. And also a big shout out to the University of Dundee security team. Thank you enormously for opening up the building for us so that we could have our event here, to Jonathan Urch as well, because without him we wouldn't be here, because he is our official first aider. And so without a first aider, there would have been no evening lecture. To Professor Blair Grubb, again, I know you're very busy, and thank you very much indeed for coming to open the lecture. It was a real pleasure to have you join us this evening. And thank you very much indeed for all of your attention